Let's divide x squared plus 2x plus 2 by x minus 1 and we'll find the remainder. We'll do this using the long division method. X squared divided by x is x. Now we'll multiply x with x minus 1 to get x squared minus x. On subtraction, x squared gets cancelled. 2x plus x becomes 3x. We'll bring down this 2. Now dividing 3x by x, we have plus 3. On multiplying 3 with x minus 1, we get 3x minus 3. On subtraction, the 3x terms gets cancelled and 2 plus 3 will give us 5. This 5 is our remainder. Now, let's understand what the remainder theorem is. Instead of doing the long division and finding out the remainder, you can find it out in a single step. When any polynomial p of x is divided by x minus a, then the remainder will be p of a. Let's understand this clearly. In the example which we just solved, this is the polynomial p of x and this is our divisor d of x. Our theorem states that when you divide by x minus a, then the remainder will be p of a. So in this case, a is 1. Let's find out what is p of 1. To do that, we have to just substitute 1 in the place of x in our polynomial. So we have 1 square plus 2 into 1 plus 2. 1 plus 2 plus 2, which is 5. In a single step, we could find out the remainder. But don't you want to know why this is true? From this division, let's note the quotient q of x as x plus 3 and the remainder r is 5. Now listen carefully. When you multiply the divisor and the quotient d of x into q of x and then add the remainder to it plus r, what will result is our original polynomial p of x. In this statement, let's replace d of x with x minus 1. What we have is p of x is equal to x minus 1 into the quotient plus remainder. In this statement, let's find what happens when x is equal to 1. P of 1 becomes 1 minus 1 into the quotient plus remainder. 1 minus 1 is 0. So this whole term becomes 0 and we are left with the remainder r, which means p of 1 is the remainder r. This proves the remainder theorem. Now, let's say we have the same polynomial divided by x plus 1. We'll remember here that from our divisor, we'll have to change the sign of the constant term. So, let's find p of minus 1. Minus 1 the whole squared plus 2 into minus 1 plus 2. This becomes 1 minus 2 plus 2, which is 1. Let's verify using long division. You could pause here and do the long division yourself. Here as well, we get a remainder of 1. With that, we'll move to our last example. Find the remainder when x cube minus 3x squared plus 4x minus 12 is divided by x minus 4. Let's do it using remainder theorem and verify using long division. P of x is x cube minus 3x squared plus 4x minus 12 and d of x is x minus 4. From the divisor, let's take the constant term minus 4. Change the sign plus 4 and find p of 4. 4 cube minus 3 into 4 squared plus 4 into 4 minus 12, which is 64 minus 3 into 16 plus 16 minus 12. 64 minus 48 plus 4, which is 20. So, our remainder is 20. On verifying with long division, we get a remainder of 20 again. Let's quickly revise the theorem. When a polynomial p of x is divided by x minus a, then the remainder will be p of a. If you found this video helpful, give it a like and share it with your friends.